When deploying emergency communications under austere field conditions, the priority shifts from chasing low angle DX to establishing rock solid, predictable local and regional circuits. An emergency antenna system must meet three strict criteria: rapid mechanical setup, minimal reliance on lossy antenna tuners, and physical resilience against wind and unpredictable soil conductivity. In a disaster, your most critical traffic usually lies within a 0 to 400 mile radius. Standard low angle verticals skip right over this zone. Near vertical incident sky wave (NVIS) reflects signals almost straight up into the F layer to blanket the surrounding region without skip zones. Low suspension inverted V dipole, a 40 meter or 80 meter dipole supported at only 15 to 25 feet above the ground. Lowering the feed point intentionally drives the radiation pattern upward, maximizing high angle radiation 60 to 90 degrees while virtually eliminating ground wave phase cancellation. A lightweight fiberglass telescoping mast and 3 bungee corded stakes make setup a 5-minute task. Tactical cross dipole for pure omnidirectional NVIS coverage. Two orthogonal dipoles, that is at right angles to each other, typically cut for 40 meter and 80 meter, share a single feed point at the top of a 15-foot mast. The dropping wire legs act as both the radiating elements and the structural guy lines for the mast. When you need agility across multiple frequency bands without stringing heavy open wire feed lines or swapping links in the rain, N-fed architectures excel. N-fed half wave with 49:1 union, cut to a resonant half wavelength at the lowest desired frequency, example 66 feet for 40 meter, and EFW presents a naturally resonant high impedance feed point across fundamental and harmonic bands 40 meter, 20 meter, 15 meter, 10 meter without requiring a heavy antenna tuner. It requires only one elevated support point deployed as a sloper or inverted L. Critical field detail. Because the coaxial shield acts as the secondary return path, you must place a high impedance common mode choke, that is 1:1 current balance, roughly 0.05 wavelengths down the feed line to prevent RF from traveling back into the operating tent and causing common mode noise or equipment lockups. Random wire with a 9:1 union. If physical space restricts a full half wave, a non-resonant random wire such as 41, 58 or 71 feet paired with a 9:1 union offers continuous spectrum coverage. However, it requires a wide range internal antenna tuner unit and a dedicated elevated counterpoise wire or multiple ground radials to prevent severe ground loss inefficiency. Handheld transceivers operating on 2 meter and 70 cm are the backbone of local incident command sites, but their standard rubber duck antennas suffer from negative gain and body shielding attenuation. Getting the radiator elevated above local clutter is imperative. Roll up 450 ohm ladder line Slim Jim. Weighing only a few ounces, a Slim Jim or J-pole constructed from 450 ohm window line rolls up into a pocket. It provides roughly 3 dB of real omnidirectional gain over a standard quarter wave whip and an exceptionally low radiation angle. Tied to a small throw weight and hoisted 30 feet into a tree canopy via paracord, it can instantly extend an HT's simplex range from 2 miles to 15 plus miles. Portable 3 to 5 element Yagi. When communicating out of an austere site to a distant mountaintop repeater or establishing a dedicated packet or WinLink gateway point to point, a lightweight broken down Yagi is indispensable. Mounted on a surveyor's tripod or clamped to a signpost, the directivity cuts through high localized noise floors. Field deployment best practices. Pre-cut and color code elements. Never measure wire in an emergency. Pre-tune your dipoles and EFHW wires using an antenna analyzer at home. Trim them for your preferred emergency communication net frequencies and mark the tie-off points with high visibility heat shrink tubing. Feed line strain relief. BNC or UHF, that is SO239 connectors, will snap off under the lateral weight of unsupported RG8X or RG58 coax buffeted by wind. Always anchor your feed line mechanically to the support mast or a structural stake using reusable rubber wire ties or velcro straps. Ditch the ground rod for RF return. Driving an 8-foot copper ground rod in rocky or frozen soil is often physically impossible and does little for your RF ground plane. Rely instead on elevated counterpoise wires, draping the wire over the tops of bushes and shrubs or suspended a foot off the ground to isolate your return currents from severe ohmic soil losses.